Hello everyone, it's Asatya Games. Today I will be showing how you can develop a roguelike game with Defold. At the end of the tutorial, you will have a game like this if you follow along. We will have a player, some skill slots which will be filled. When we pick up new skills, we can get XP. We can have different weapons with different mechanics, different monsters, HP, and so on. This tutorial will be a lot longer compared to previous tutorials. It has many resources, many scripts. Before explaining the scripts, I will first go on the resources, how you can create them, what are their properties. You can first create this while following the tutorial. Then I will explain the scripts so we can attach them to the game objects and other resources or the GUIs to control them. Now let's get started. Our game has different enemies. Since enemies will be spawned with factories, we will need them as separate game objects. So on the resources folder, we will have them as game objects. Before starting, you can create asset folder, resources folder, and scripts folder. On the assets, we have some assets. Some of them are from previous tutorials and some of them are new. They should be on the credit file. To be able to use these assets, we will need them in the formats of Atlas or tile source. That's why on the resources, we will first create some tile source and Atlas. To create the tile source, right-click, New, and select tile source, name it tiles. So it will be tiles.tile source. On the tiles, set the tile width and height to 128 or something different if you are going to use different assets. With tile source, we will need animations to be able to use the tiles. When you attach the tile source, you will only be able to access to the animations. That's why for the assets you want to use, on the tile source, right click, add animation. For example, armor, name it armor. Armor is at the tile 16. You can see it on the top left. Set its start and end tile to 16 because it only consists of one tile. FPS doesn't matter with this one. It will have no playback. If you press space on the animation, you can see the animation. If you have more than one animation, you want to play it like bat. As you can see, it's being played. It starts at the tile 7, it ends at the tile 8. So we will loop it forward and its FPS will be 30 at first, but it's too fast for this animation, so I will set it to 5. You can do the same with ghost, skeleton, and the player. If you are going to use a tile source, animations needs to be in an order. You can't select one tile from here and the other one from here to play the animation. For this game, you will have something like this. After this tile source, I have another tile source, which is map tile source. This is the original tile source I have found on itch.io. You can find the link on the credits file. As you can see with this tile source, tiles are separated, so we can't use it with animations. That's why I have separated them and placed them in order to be able to play the animation. I have this separate tile source because I wanted to use some border tiles which will have collisions to stop player from going outside of the map. After you create a new tile source and name it map.tilesource, select the image you want to use. I will use tiles 128, and for the collision you can select the same image, and Defold will create the collision shapes automatically, but they will not be colliding with anything. If you want them to collide, you need to add a new collision group. I added one and named it tile map. On the tile map, as you can see, some of these tiles have a red-like background. If I click a new tile, it will become red, which means it is a part of this tile map collision layer right now. If you want to delete the collision, go on the tile source and click on it so it will be removed. This basically will be used for the collisions. I have selected the walls for the collision, and this is for the tile sources. Then I have right-click the resources, add new tile map, and on the tile map I have created a 100 to 100 map. It has only one layer. On the layer, if you press space, you can select the tile you want to use, and you can just draw with it. If you press shift and select a bunch of tiles, you can use it to draw multiple tiles at once. I use this to create this square-like map where player will be able to move free in it, and walls will prevent him from going outside. Then we have two atlas. One is image atlas, which I don't think I have used with this tutorial, so I will just delete it. I have my UI atlas. If I open my main.ui, I just copied and pasted this from my main menu tutorial. It's exactly the same. I will explain how this works in this tutorial too, but if you want a more in-depth explanation, you can go to the tutorial. And with this GUI, I have used assets from this UI atlas. For this, right-click, new atlas, name it as you want. On the atlas, right-click, add image, and select the image you want to add. On the main menu, we have a sound button, which will change icons from sound on to off. And if you want to be able to change the sprite, you need to have it as an animation group. Add an animation group, name it as you want, and add the sprites you want to add here. So I have sound on and off as animations. And with this, we can now use our assets. Now we will need a bunch of game objects. First, let's take a look at the enemy game objects. The first one is bat. Bat has a sprite. I have selected the tile source and select the bat animation. If I press space, will it play it? Yes. You can change the scale and rotation of the sprite. You can move it around with arrows. Then, since this is an enemy, we will need a collision object to be able to detect it. So right-click, add component, and collision object. On the collision object, you can right-click, add shape and sphere. You can move it around. You can change the size by dragging right and left or up and down. I think this is a new feature with Defold 1.10. Then on the collision object, we will set the type to trigger because we don't want enemies to have collisions. If you want them to collide with objects with each other, then you will need to add another collision object and set it to dynamic. But we don't need that. So I will just have our collision object set to trigger. It will be in the group of enemy, and it will see player reached group. This is when the enemy reaches the player, so it will decrease the player's health. This is the player group, which player will use to detect if an enemy is in the range of fire, so he can shoot them. And they will also be hit by the bullets, so it needs to see the bullets too. Group is where you are. He is on the enemy group, and he sees and interacts with the masks. You can have only one group. You can't add new groups here, but you can see many groups by putting commas between them. I will not explain the script right now. You can repeat the same with Ghost and Skeleton. They are basically the same with different sprites. So it's easy to create the enemies. Now we also need to create our bullets. One is arrow. Similar to enemies, it has a sprite, again from the tile source and selected correct animation. It has a collision object, again set to trigger, and it is in the group of bullet, and it sees only enemies because bullets will only hit the enemies. It's the same with the axe and trap. A collision object set to trigger, bullet and enemy, a sprite with the correct animation. We also have an experience object because after the monster dies, we will need to create an experience orb. And it also has a collision object with trigger. It sees one player reached and another is player. This one will allow experience to go towards the player when he is close enough, so it will follow the player. And this is when it reaches the player, so it will increase the player's experience. It is in the XP group. This time we have two sprites. To add a sprite, you can right click add component sprite. We have a large sprite and small sprite. Large is this yellow godlike sprite, which will be used when XP's value is large. And we have a small sprite. This will be the basic experience bad drop. You can have more sprites if you need, but 2 will be enough for this tutorial. With this, we will be done with the game objects and the asset related objects. And we can close the resources tab. And on the main, we will need to create some collections. At first, you will only have your main collection, which will be empty. We will need to create a scene parent here, but before that, we actually need to have a scene. So right click, new collection, which is here. Name it GameScene.collection. On the GameScene.collection, I have added a bunch of game objects. To add a game object, right click and add game object, or you can press A. Then name it camera parent. On the camera parent, right click, add component, select camera. We have a camera component. On the component, select the orthographic projection and set the orthographic zoom to 0.8. If I set this to 2 and play the game, you will see that it zoomed too much. You can increase and decrease it as you like. Then we have a script here. While I will be explaining other scripts later, since this is a short script and I basically use it for almost all of the tutorials, I will be showing it. What this basically does is to enable the camera. During the update, it gets the player's position and lerps its position to the new position to get to the player. Using lerp will allow a smooth follow to the player. Then add another collection, name it enemy spawner. It will be spawning 3 different type of enemies. So for this we will need factories. With default you can create game objects with factories. For this, right click, add component, select factory. On the factory, name it bat and select the bat game object. Do the same with ghost and skeleton. We will have an enemy spawner script to control these factories and spawn enemies. It will increase the enemy difficulty as the time goes, and it will also decrease the interval between enemy spawns. Then we have an XP spawner game object. Again, create a game object, add the factory, select the experience game object. This doesn't have a separate script because we will be accessing this from other scripts to create the experience basically from the enemies. When an enemy dies, it will access this factory and create an experience using it. Then we have another game object named GUI. I have added the GUI here, which is skill UI. For this, you can right-click, add component file, and select the UI you want to add. We have another game object named music. It has a sound component. Right-click, add sound. On the sound, select the sound you want to play. I have selected the piano background music. You can't use MP3 sounds with default, so you need to have them as OGG. You can use Audacity to convert MP3 to OGG. Click the looping so it will loop, and do not stop after playing it once. We have a player game object and tile map. I will first explain the tile map because player is more complicated. On the tile map, we have a collision object. You can right click, add component, select collision object. On this collision object, we will be selecting the tile map we created on the resources part. So it will automatically detect which tiles have collision, so apply them on it. Then you can right click, add component file, and select the map.tile map to add the map here. Now we have our player game object. Let's see what it has. It has 3 factories. Each factories are named after a bullet we will be spawning. One is arrow, other is axe, and last is trap. Select the correct game object. We will be using them to create and shoot arrows, axes, and traps. It has a sprite, which I have selected the tile source as image and default animation as player male. Then it has 4 different of collision objects. Let's see what they do. First, we have a dynamic collision object. Its type is dynamic, and this collision object will be the collision that stops us from going through the walls. Since tile maps collision object is set to static, it will interact with dynamic collisions too. So on this, we will be on the default group and we will collide with tile map. This basically will stop us. If you set the collision object to dynamic, you will see player falling down. That's because of the gravity. To change this, you can go to game project, search for gravity, and set the gravity y to 0. With this, your player will not be affected by the gravity. This works if you are making a top-down game, but if you are making a platformer, you may need to use a different approach, but it works with this one. Then we have a reached player collision object, which is this blue circle. It is a trigger game object and it is in the group of player reached. This will be activated when an enemy hits the player, when an experience hits the player, so player can take the correct action. It will also need to detect the bullets. Normally you don't need to detect the bullets with the player because player will not be affected by the bullet, but for this game I have added a spinning axe as a weapon, and when you throw it, it comes back to you, so you can collect it back to throw it again. For this, player needs to see the bullets too. Then we have an XP pool collision object. This is the part and XP needs to be in for player to start pulling it. We also have the hit range. This is where the player can hit enemies. So we are in the player group and we will see the enemies. We have a script to control the player, but I will explain it later. We have a GUI. On the GUI, we have skill UI. If you want to create a GUI, a UI component, you can right-click, add new GUI, which is here. Name it main menu. On the GUI, you will have some folders. One is for nodes, one is textures and fonts. On the fonts, right-click, add fonts, and select the font you want to use. If you don't add the font here, you won't be able to use text features, so make sure to edit. add the textures you want to use. Here with adding textures, you can add tile sources or atlases. I have this UI atlas, so I will be using it. That's why I have added it. I have explained this on the main menu tutorial. You can find it on there easily. To add a background, on the nodes, right click, add a box, and you can set its texture to, let's say, background. You can get it here. You can scale it up. You can change the size mode to manual. With manual, you can select the slice size. It will be taken from the sprite. So this is the part that will be expanding. This will only expand horizontally, and this will only expand vertically, while these don't expand at all. You can change the name of it here. You can change the rotation, scale, and so on. For this, I have added a box and name it background. Set the background texture. Set the manual slices with 32, which can be changed to 16, and it wouldn't actually matter much. And it will work the same. Then I have added another box, name it start button, select the button as the texture. I have set the size to 64 by 16 and scaled it by 5 to be able to see the borders better. If you just increase the size, the borders will be relatively small, so you won't be able to see it properly. On the start button, right click, add text, and on the text, I have set the text to start. You need to select the font. You can change the color here. Copy and paste the same button and move it downwards. Name it exit button. You can change the texture and you can change the text to exit, set the color, etc. Then on the nodes, right click, add a text for the title. I have set it to Vampire Survivors like Roguelike game. It's basically a roguelike game. It has similar mechanics to Vampire Survivors. I have used the name because it's popular, but it doesn't look like it at all. But using this tutorial's approach, you can basically copy almost the whole game. But of course, plenty of addition. Then I have added another box and name it soundbox. On the box, I have added first a text for this sound, and I have added a pie for the image. You can use a box too, it works. And this is basically the whole main menu we have. With GUI, you can't use normal scripts, so for this you will need to create GUI scripts. I will explain how this works when I explain the scripts. Then we have another GUI, which is the game UI we will have. It has 3 boxes for skill selections. I have added boxes, and under the box we have another box which is smaller, so we will have the weapon texture there. We will be changing the textures. Other boxes also have textures, they are just not enabled, so when we select a new weapon, we will enable it and change the texture, so it can stay like this. Then I have added another box for HP bar. HP bar is basically a box and a smaller box in it. The outer box has white color while the inner one has red to show the hit points. For the bar to work, you will need to change the pivot point to west, so it will be pivoted to here. That's why if you change the size of the Y, it will, as you can see, move along the bar. If you have it in the, let's say, center, and if you change the value, it will decrease from both sides, and this is not what we want. So you can set it here. After the HP bar, copy and paste it. Move it like this to the left and set its name to XP bar. On the XP, set the color to blue. Since the settings are correct, you can just scale its X value by 1.7, so it will look longer. We have a level text and HP text. We don't need the HP text to have a special name, but we will be accessing the level name to increase the level. Additionally, we have two screens. One is selection background screen, which is the screen we will see when we get enough experience to level up. And I have added a bunch of nodes under it, so when we hide it, all the other nodes will also be hidden to make things simpler. Added a title that says select one skill. I have added a text, name it skill one name, and I have enabled the line break, so if you add new words here, it will automatically break the line, so it will not overflow. We have an image, which is again just another box, and its name is skill1 image. And lastly, we have a similar text to name, which is description. It again has the line break enabled. After you are done with this, copy this and paste it twice. Move it to the right and set them as you want. Change the 1 to 2 for option 2, like skill2 name, skill2 image, to make things simpler. Then do the same with option 3. With this you will have 3 buttons, and they will be setting their values from the script, so they will show different values, and when selected we'll have different results. Also, we have a basic loose screen, which only has 2 things. One is a text that says you lost, and another is a box with replay button. On the button I have added another text that says replay, and I have set the reply button's color to blue. I didn't set any textures on it. And this basically concludes the in-game UI we have. To be able to use them, we will need some collections. First, we had our game scene collection. On the collection, we have a game object named GUI. Right-click, add component file, and select the skill UI. GUI you have created, so we will have it in the game. And then create another collection named main menu collection, and on it add a new game object and attach the component file of the main menu GUI. On this collection we also have a component named music, and it has a sound component that plays menu music, again in OGG format, and its loops. We will be controlling this from the main menu GUI, so the sound will be played. After this we will have all our resources and collections, so we can go to our main collection and add a game object as scene parent. This scene parent will control the scenes. On the scene parent, right click, add component, select collection proxy, so we can use this to load and unload collections. We will be loading game scene collection with the proxy named level and main menu with proxy named menu. And with this we are officially done with creating game objects and collections. Now all we have left is some scripts, and we will create this bunch of scripts, attach them, and the game will be finished. Now on the second part I will explain what these scripts do, how you can create them, and where you should attach them. On the scripts, right click, new Lua module. I will be explaining the first module and name it GameManager. Modules are basically public classes that can be accessed from other scripts directly. We can use this to communicate between scripts. We have a variable named isSoundOn, and this is accessed when we turn the sound on the main menu. This is set to true, and when turn it off, it's set to false. So we will use this to know if we should be playing the sound on the game. Let's see it. Now the sound is on, so if I play, you will see that the game sound is also played. But if I turn the sound off and play the game, you won't be hearing the sound. It's thanks to this variable, because we know if sound on is false, so we do not start playing the music on the game scene. We have a poison damage value. When player selects the poison damage skill, this is increased by I think 3 or 5. So monster that were hit once starts getting poison damage. We have an HP, max HP, and armor value. These are values of the player, and player's XP will be 0. Player will need to have 25 XP to level up, and player will be level 1 at first. We have these variables. One is attack skill amount. We have some skill boxes here, and at first it is 1 because we have our arrow skill. If we select another skill, let's say we have selected axe, it will go to the second box because our skill amount will be 2. So it will set the sprite of this box to the axe, and when we select the trap as a new skill, we will increase the skill amount 1. It will go from 2 to 3, so the third box's texture will be set to trap. We have a speed variable that is 300 for player to move. We have some tables for monsters, and this basically keeps the speed, HP, and attack values of the monsters. Bats are slow, has low HP, and weak. Ghosts are fastest, but they don't reduce the HP that much. Skeletons are a bit slower, but has high HP, and they are strong. These are the values we need to keep. We have a function that we will use when we replay the level. When we die, game will allow us to replay the game. So I basically copied the values and pasted them here and put m dot at the beginning of them. I have only pasted the values that will be changed during the gameplay. We won't be changing the enemy stats. If you are going to change them too, then you need to set them to their original values on the reset game function. Then there are a bunch of set and get functions. You can actually just access the value by using GameManager that is sound on, and it works. But it is not a good practice, but there are just so many values, so I didn't want to create set and get for each variable. So some of the values will be accessed using get and set, and others will just be accessed using GameManager.value. Now I will start explaining the bullet controller first. On the script we have an init function that is called at the beginning. This works like the start on the Unity and ready on the Godot, I guess. We just set some speed and attack values. We have a direction, and we have a type value. All of them are on our self table. We also have two variables, which is axe counter and time to return. These are the values that will be only used by the axe. This bullet controller is attached to each of the bullets, so all of them has the same script, but they will behave differently because we first set different values to them on the onMessage function, and on the update we control them depending on their type. On the message, if we get a message named init arrow, that means we are going to be an arrow. That means we are attached to the arrow game object. So we set the speed, attack, direction, and type from the message. Arrow and axe logic is basically identical, but it is different on the trap. Traps are going to act like mines. They will stay at where they are, and if a monster collides, it will hurt the monster, so they don't have any direction or speed. That's why it only gets the attack and type value. Then we have another message, which is trigger response. Since our collision object is set to trigger when it collides with something it can detect, it will send a trigger response with a bunch of information. It will have the group of what it has collided with, and if we have collided with enemy, then this is for debug. We send a message to what we have collided with that says change HP, and as the value we send our attack multiplied with -1 to decrease the health instead of increasing it. If we are an arrow, after hitting an enemy, we will need to disappear. So if our type is arrow, we use GameObject.delete to remove ourselves. If we are a trap, then we again delete ourselves. But before that, we send a trap return message to our player, because player will have a trap limit. Let's say you can lay 5 traps at most. After setting 5, player will not be able to create any more traps, and after an enemy activates the trap will delete itself, so player will be able to throw another trap around. To enable this, trap says I have returned, so you can use it again. Axe does not disappear when it hits an enemy. It pierces through, so it does nothing if the type is axe. But for axe we have a different check. If the thing we have collided is in the player reached group and we are an axe, and that means we have returned to the player. Same with the traps, player can only throw a certain amount of axes, and they need to return before player can throw them again. You can access the player like this because they are on the same collection, or you can just use message.otherID. These are two different approaches you can use. Then it deletes itself. We also check if it is time to return. We do this because when player first throws the axe, it collides with the player and player automatically collects the axe back, so player cannot throw it at all. To avoid this, we first create a time to return value set to false, and we will set it to true after some time, so axe will move certain amount of time before we can collect it back. With this, player will be able to throw it. Then on the update, we check if our type is arrow, our direction's length is greater than 0, so we have some direction value set, it is not null. Then we first get our position with the GameObject.gamePosition. To our position, we add our direction that is normalized. We normalize it so it will have the same speed towards each direction. We multiply it by speed, and we also multiply it by delta to have a consistent speed across all devices. After we changed our position value, we can use GameObject.setPosition to set our new position. We also check if we are an axe. If we are an axe and we have a direction, then we do the same with the arrow. We go towards our direction. The difference between axe and arrow is once you set the direction of the arrow, it will follow that direction and you don't need to calculate it again. But with axe, it will act like a boomerang. We will first throw it, it will go towards some direction, it will check if it has reached the player. If it has not, then it will go towards the player till player collects it. We get our rotation, we set a spin speed, so if axe will spin. Then we use these lines to set the rotation of the axe. Axe counter is the timer we will be using to check if we need to change our direction after 1.5 seconds. So we decrease it by delta and check if it has reached to 0. If it is less than 0, That means 1.5 seconds has passed, so we need to get our direction again. We set our direction towards the player, so we get player position and decrease our position from it to get a vector that is directed towards the player. We set the counter to 1.5 seconds again, and we also set the time to return value to true. So after you throw the axe and 1.5 second passes, that means you can then collect the axe after you collide with it. We don't check for the trap because trap will not do anything. It will wait. If an enemy hits it, it will reduce the enemy's health and send a message to player before destroying itself. This is how the bullet script works. I have already explained the camera parent script. It follows the player smoothly. It has its own tutorial. We also have a script named enemy controller. Enemies are being controlled by this script, and all of the enemies have the same script. On the change HP function, we add the value to our HP. We send a negative value, so we decrease the monster's HP. We also set the is poison to true. This value is set to true when monster is hit, but if we don't have any poison damage, we can apply to the monster. It will not change the enemy's health, so it is alright to change it here. If after reducing the HP, enemy's HP is less than or equal to 0, that means enemy needs to die. So we first send a message to the player to remove the enemy. Player keeps the track of the enemies that are close to him so he can shoot them. We use this message to remove the enemy from the table. We keep them, so we will not try to shoot it even after we delete the enemy. Then we access to XP Spawner's factory. As I said before, this factory didn't have its own script, but we access it from the enemy to create the XP. We create an XP and save the XP's ID to Exp ID. We first create a local variable named XP type and set it to small. If our type is ghost, then our XP type needs to be normal. And if our type is skeleton, our XP type will be big. Then we send a message to the XP that says set type, and as the type value, we set the XP type value. After monster is removed from the player's table and it has created an XP, then it can remove itself with GameObject.delete. On the update function, we get the player's position, we get our position, we calculate the direction by reducing our position from the player's position. This creates a vector from us to the player's position. We normalize the vector for consistency, and we add it to our position after multiplied by speed and delta. Our monster sprites are looking to the right, so if our direction's x value is less than 0, that means we are going to the left, so we need to horizontally flip the sprite, so we use this line to flip the monster sprite. We set our position that we calculated here. Then on our set table we have a counter variable and we increase it by delta and check is greater than the poison interval. That means it is time for us to get poisoned. Then we change the HP by the poison damage of the game manager, but we need to multiply it by -1, so it will actually reduce our health and not increase it. After that, we set the counter to 0, so we can again count till the poison interval. On the onMessage function, we check for different messages. If the message we get is a trigger response, that means we have collided with something, and the thing we collided is in the group of player reached. That means we have reached the player, so we reduce the player's HP by sending him a change HP message with the value of -self-attack. We send it to the message.otherID, then we remove ourselves. If the message we received is change HP, That means we are hit by something. We create a local value variable and get the value from the message. If there is no value from the message, then we set it to 0. This is just to be sure, but it is not exactly necessary here. Then we change the HP by the value. We also check if we get the set type message. We will get this message after the enemy spawner creates the monster. It will send the set type message, and on the message we will also send a type variable, so it will set our enemy type. Then we create 4 variables on our start table. Poison interval is 1.6. Our counter starts from the 0, and we are not poisoned yet. We need to be hit by something before we start taking poison damage, and we set our type to enemy type. If enemy type is bad, then we get GameManager's bad table and find the speed value on it. We do the same for HP and attack, and if it is ghost, we get it from the ghost, and we do the same for skeleton. This allows us to use the same script for different monsters. Since we have our enemies and we can control them, we also need to spawn them. So we have an enemy spawner function on the enemy spawner game object of the game scene collection. This one has the script. Now on the init function, we first create 4 variables on our set table. One is the spawn range. This is how far the enemy will be from the player. It is 600 pixels, which works the same as the counter from the enemy controller, and we have the interval, which is 2 seconds, and we have a spawn value of 10. We will be using this value to increase the difficulty of the monsters. We have a helper function that allows us to rotate a vector by some degrees. We have our spawn enemy function. We first create a bunch of values. One is degree, which we get a random degree and player's position. Then we create an offset vector, which has the x value of the spawn range, and y and z values are 0. We rotate the offset with rotate vector function by the random degree we found and set it as rotated offset. Now we have a vector which is rotated by some random degree with the length of 600. Then we calculate the spawn position by adding the offset to the player's position, so monsters will always spawn around the player but with some offset. Before creating the enemy, we create 2 more local variables. One is enemy type and the other is selected factory. Then we get a random value from 0 to the spawn value. Our spawn value was 10 at first, so we will get a value from 0 to 10, and it will obviously be less than or equal to 10. So our first spawned enemy will be a bat, and it will use the bat factory. As you can see, we increase the spawn value with every monster we spawn. So as we spawn more and more monsters, spawn value will go up to 20 or 30, so it will be possible to get the value of 15 or 25 as values. So when that happened, if the random value is less than 10, it will have the bat. If it is greater than 10 but less than or equal to 20, it will be a ghost, and if it is greater than 20, it will be a skeleton. With this, it will allow a dynamic difficulty increase, and as the game goes on, the value will increase too much. Let's say if it reaches to 100 as its value, then that will mean most of the values selected randomly will be greater than 20, so most of the enemies are going to be skeleton. So you can put a limit to the spawn value like this. If that spawn value is greater than or equal to, is less than or equal to, let's say 40, then we can get this value to here and end. So right now it will only increase spawn value up to 40. so it will not get to the point where all of the monsters become skeletons. This is a difficulty limit. You can increase or decrease it for different difficulty settings with your game. After we select the type of our enemy, we call factory.create to create the enemy. We use our selected factory and it spawns at the spawn position. We don't send any additional value, but we save the enemy ID as a local variable and we send a message to it that says set type, and on the message we have a type value that is enemy type. This is the set type message we get, and it has a message.type, as you can see. On the update, we have a timer, and if the timer reach to the spawn interval, then we spawn the enemy. We set the timer to 0 and we decrease the interval by 0.02. So this means enemies are going to be spawned faster and faster. That is, till the interval reach to a value less than 0.5. So it will not get to the point where it becomes impossible and monsters are spawned constantly. We have our experience script. On the init function, we create two values. One is the XP value. This is the value player is going to get when XP reaches to the player, and we have a self that is in range value. If is range is true, that means player has been close enough to us, so we get our position, place position, calculate the direction, and go toward the player with the speed of 220, and we set our position. This basically allows experience to fly towards the player, but only when player has been in the range. On the message, we check for two different messages. One is the set type. We will get this set type from the enemy controller. Here we send a set type message to the experience, and if the set type's type is small, that means our XP value is going to be 10. We will enable the small sprite and disable the large sprite, so we will see the gray ball with the value of 10. If it is not small, then we are going to enable the large and disable the small, so we will see the yellow one. If message type is normal, then the XP we gain will be 25, and if it is big, then it is going to be 50. We also check for trigger response, and we add message.enter, so this will only be called once at first when we collide with the experience, and it will not be called many times. If the group of the object we have collided is player reach, that means we have reached the player, so we send a message to the player that says gain XP, and we send our XP value as the value, so player will be able to increase its experience by this amount, and we remove ourselves. If the message group is player, this was the middle-sized collision shape around the player. That means player is in range, so we set the value to true, and it will allow us to fly towards the player. Now we have a GUI script. If you want to create a script, you can go new and script. If you want to create a Lua module like GameManager, then you can select this. But if you want to create a script to use on the GUI, then you can select this one. So for the main.gui, you will create a GUI script. It requires the GameManager. On the init function, we get some nodes using GUI.getNode. With default on the GUI, all nodes have to have unique names. Thanks to that, we can just use the node's name to get the node. Named soundbox, we have a sound icon named image, we have a start and exit button named start and exit button. Buttons are obvious, and this is the image under the soundbox. We acquire input focus. We start playing the sound on the music game object sound component. Gain is how loud the sound. After that, we update the sound icon using GameManager's isSoundOnValue. isSoundOnValue was true at first, so we call this function with true as the value here. On the update sound icon, we change this image to sound on and off. If it needs to be on, then our texture is sound on. If not, it will be sound off. You can just write it like if is on, then texture equal to sound on, and you can add an else to here too, but this is simple one-line code. Then we set the game manager's isSoundOnValue to is on. We also use GUI.playFlipBook to change the texture of this box. We get the image node, which is our sound icon, but this function doesn't take a self value. That's why I didn't use the self.sound icon here. And we set it to sound on or off depending on the is on. We also have sound.pause function, and it stops the sound if is on is false. Not false is true, so it will be paused. And it continues to play when is on value is true, because not true is false, so it will not pause. We also have onInput and onMessage functions. On the onInput function, we check if right click is pressed. I have a left click or right click, left button mouse or right button mouse. I also have left, right, up and down binded to WASD. So we check if left click action is done. We have clicked and we just pressed. With one press, we won't be calling this a few times. Since we have clicked, we check where we click. If we clicked on the sound box, then that means we want to change the sound value. So we change the game manager's is sound on to not is sound on. So we basically reverse it. Then we update the sound icon. If we have pressed the start button, then we send a message to our scene parent that says change scene, and the scene we want to be on is level. This will start the game. If we are on the exit button, we use os.exit to close the game. You can use GUI.pickNode to check if a point is on the button. And on the onMessage function, if we ever receive an update sound icon message and it has a sound on value, which may be true or false, then we update the sound icon. After that, we have our player, but since player has a long script, I will first explain the scene parent. Scene parent is a script, so you can right click new script. The script uses Game Manager, so it requires it. On the init, we first get input focus, but if you look to the script, you will see we don't have an onInput function, because if you want player to be able to detect input, then all its parents needs to be able to detect inputs too. So we get the input focus on the scene parent too. On our self table, we create a next scene value. Then we send a message to menu, which is this one, and tell it to load. Since this is a collection proxy, once it received the load message, it will load the collection, and after the collection is done, it will send a proxy loaded message. On this script, we handle two things. One is to change the scene between menu and the game. Then the other thing is reloading the current level. When we play and die, player will be able to reload the game. We first check if the next scene we want to be on is level. So we need to check on what scene we are on currently. If we are on the level scene already. That means we want to reload the scene. So we unload the current level. When a collection is unloaded, it sends a proxy unloaded message, but this message is sent every time we unload a collection. It could be menu, level, or something else. We also need to make sure our current level is reloading level. That means we want to reload, so we send a load message to the level again. So after we are done unloading it, we load it back, and with this we basically reload the scene, and we set the current level to level, so this will not be called again. If the new scene is level, but we are not on the level, that means we are on the menu, so we unload the menu and load the message. If we want to go to the menu, that means we are on the game, so we set the current level to menu, we unload the level and load the menu. Just calling the load on the proxy isn't enough. Once it is loaded, we need to enable it, so on the onMessage function, once a collection is loaded, it will send proxy loaded message, so we will enable the sender. I have just explained this part. This allows us to reload. If the message we get is change scene and it has a scene value sent with the message, then we switch to the message scene. If we send a toggle sound message here, then it will toggle the game manager's sound on value. We only have 2 scripts left, but unfortunately they are the longest. This is the player script, and this is the skill UI. This handles the player, so let's start with the player. On our self table, we create a bunch of new variables. One is a speed variable set to 330. We create some new tables on our self table with values belonging to the arrow, axe, and trap. This holds their speed, attack, counter, interval, and amount. Speed is how fast it is going to move. Attack is the damage enemies will get when they are hit by it. Counter is set to 0 because it will count till the interval, and once the counter is done, we will attack with it again. And the amount is how many of them we have. We start with only 1 arrow, but we can increase their amount with the skill selection. Others also have similar values, but trap does not have a speed value as it is not moving. We create a direction vector, and we create a table for enemies in range. We will use this to keep the track of the enemies close enough to us so we can attack. Then we acquire input focus, so a player will be able to detect keyboard presses and mouse clicks. We have a helper method that returns the closest enemy. On the method, we get player's position and save it on player position value. We create a local variable named closest, and we create another variable named mean distance squared, and we set math.huge value, so this will be larger than any value we calculate here on the enemies in range with their ID. So we iterate through the table and use their ID. We check if the enemy exists, so it is not dead yet. Then we get its position and we calculate the distance from us by using vector math length squared. Then we check if the vector calculated is shorter than the minimum vector we have. That means this monster is closer, so we update the minimum distance and set its ID to the closest, and at the end we return the closest monster. Let's check our update function. On the update, we first get our position. Then if the length of our direction is greater than 0, that means we are going towards some direction. So we calculate the new position we need to be, and we set our position. This will allow the player to move around. Then we set the direction to an empty vector, so player will not keep moving even when we are not pressing. On the function, we have 3 similar parts. On these parts, we increase the arrows counter, access counter, and traps counter by delta, and if it reaches to the interval value, that means we need to fire or throw the bullet. With the arrow, we call the fire arrows function and set the arrow counter to 0. We do the same with axe and the trap. On the on input, we check if WASD is pressed. If it is pressed, we use our generic movement logic I have been using on many tutorials to make the player move. We have a change HP function. This is the function we use when we get hurt. Our game managers get HP returns two values. The first one is HP and the second one is max HP. So we save them on local variables. If the value is less than 0, that means player is going to get hurt, but we also have an armor value. So let's say enemy wants to damage you by 10, but you have 15 as the armor value. Does that mean you are going to get healed? No, you just are not going to get hit. So we get the minimum value of these two values. We first add the armor value to the value. We add the armor value to the damage value, and if the result is greater than 0, that means our value is going to be 0, so we will not get hurt. After we make sure enemies are not going to heal us up, we increase the HP by value, and we set the HP and max HP on the game manager. Then we tell the GUI to update the UI. We have a similar function to the change HP, which is gain XP. It gets the current XP and needed XP using the get XP value from the game manager, and it gets the level and save it on level. It gets the current XP player has and the needed XP for player to level up. It gets the current level of the player, and it adds the value player needs to gain to the current XP. If the current XP is greater than needed XP, that means we are going to reduce it by needed XP and increase our level by 1. After that, we are going to increase the needed XP by 35%. So this line will make it more and more difficult to level up as the player's level increase. After that, we send a skills message to the GUI. This is in a while loop because let's say the first level requires 10 XP and the second level requires 15 XP. So in total, you need 25 XP to level up twice, and you somehow get 50 XP. That means you need to level up twice, but if you just use if here, the level up will not be triggered till you get another XP, even if it is too small. So this makes sure you will get the worth of the XP you gained. This could be a problem if after beating a boss you get a huge amount of XP and you level up a few times. So it will actually work correctly with this. Then we set the level and the XP on the game manager. Then again we tell the GUI to update the UI. On the on message, we check a bunch of messages. If the change HP message is received, then we call the change HP function with the value. If it is gain XP, then we call the gain XP function. Then we have an axe return message. If we receive this message, that means an axe we have thrown came back to us, so we increase the amount of axes we have, so we can throw it again. Same with the trap. That means a trap is activated and removed, so we can lay another trap. Then we have 3 checks for more arrow, more axe, and more trap. These are from skills. When we select the more arrow option, it sends a message to the player and increases the amount of the arrow by 1. If you want to be able to increase it by 2, 3 or different values, then you will need to send the value with the message, so you can increase it by message that value. But for our case, it is 1. We only increase it by 1. Same with axe and trap. If we receive the remove enemy message from the enemy that is dying, then we check if we have it in our enemies in range table. If that is the case, we remove it. We also check if we get any trigger response. This is triggered by this large collision shape, and it detects if the monster is in range for us to kill it. Then we check if the object is entering, and it is in the group of enemy, so an enemy is entering our range. So we add it to the enemies in range table. If it is exiting, we set its value to nil. Now let's check the three functions we have for firing arrows, probing axes, and traps. In this function, we iterate through the amount of arrows we have. Since we start from the 0, we reduce it by 1 to fire correct amount of arrows. We use timer.delay to put some delay between firing arrows. Then for each arrow, we first get the closest monster. If the closest is not valid or it doesn't exist, then we return and do not shoot an arrow. If not, we continue. We get the player's position, closest enemy's position, and we calculate the direction. If the direction's length is 0, then we return. We put these checks just to be sure. We normalize the direction, then we rotate the arrow, so when shooting up, it will look up, and shooting down, it will look down, and will not look weird. After we calculate all of them, we use arrow factory to create a new arrow. It is created on the player's position and with a small offset of direction times 30. This is not mandatory, but it makes it look better. So arrows are not spawned from the center of the player, but this makes things. If I remove this, and let's increase the arrow amount to 10 to be able to see. As you can see, arrows are spawned from here, and it doesn't look good. So we add this and make sure arrows are spawned a bit far from the player center, so it looks a bit better. You can increase or decrease it as you want. After we create the arrow, we save arrow's ID and we send a message to it saying init arrow, and we send arrow speed and attack as well as direction and the type. We do the same with axes. The difference is we do not calculate the angle. Axe is going to spin anyway, so we don't need to make it look towards the enemy. We use the axe factory and send init axe message. Also, we decrease the axe amount when we throw an axe, so we will not be able to throw it back till we get it back. Throw trap function is a bit different. We check if we have any trap to throw. If that's the case, we get our position, we get a random angle, we get the direction we want to throw the trap towards using that angle, and we use trap factory to create a trap on the player's position plus direction times 300, and we send the init trap message, but we don't send any speed or direction as it doesn't move, so we only send the attack and the type. We also decrease it by 1. When an enemy hits the trap, it is going to send us a trap return message, so we will be collecting the trap back to set it again. And I think this is the all we have on the player script. And lastly, we have our skill UI. This is the logic we use here. This part. This is the GUI script that controls the skill UI. GUI, we use the GameManager on it too. So we require it. On the init, we first set the scene parents time step to 1. We do this because before we reload the level, we stop it, so game will not continue after the player dies, and we need to set the time step to 1 after we reload the game, so we call it on the init. If the sound is on, then we play the music. We use GUI.getNode to get a bunch of nodes. We get the loose screen, replay button, selection background, they are all here, selection background, option 1, 2, 3, and it has this. I will share this project on my itch.io page, you can download it. We have a self.hasLost value that checks if the player's HP has reached to 0 yet. Then we disable the loose screen because we haven't lost at the beginning of the game. We get the selection background and create an isSelectionTime value and set it to false. As you can see, we have some boolean values. The reason is that even if I hide this selection background, but the player clicks here, then as you can see, it will actually be detected by the box. So we need to make sure when we clicked, it actually meets the condition. So loose screen will only work if we have lost, and selection background will only work if it is selection time. We get the skill 2 and 3 nodes from the skill UI, which are these boxes. We get the level text, so when we level up, we can update the text. We create an options table on our cell table. It will has option 1, 2, and 3 as its values, which represents this background, and these are basically saved. Under the option, we have the node, which is the option 1 node, this one, and then we have name, image, and description. We take the nodes for each of the options. Then we have a skills table, which includes all of the skills we have with an image and description value. Image is the animation name on the tiles. We have a max HP increase image. If I go to tiles, as you can see, we have max HP increase. We will be using to change the texture of the boxes here. And we have a short description for the skill. You can add as many skills as you want here. When it is skill selection time, skills will be selected from this table randomly. Then we get also our HP and XP nodes. We set the max HP to the size of the GUI. Since they are initially full, this will work correctly. And we also acquire input focus because we are a UI and we want to know when player clicks on a skill. We call the update UI bars function. We also disable the selection background here. Let's check the update UI bars function. We get the HP and max HP from the game manager and XP and needed XP again from the game manager. If our HP is less than 0, that means we need to enable the loose screen because we have just lost, and we set the has lost to true. So when we click on the replay button on the loose screen, it will actually work. And we also set the time step to 0 to stop the game. If it is not 0, that means we will ignore this. We will first calculate the HP percent by dividing the HP to the max HP. If HP greater than max HP, it is going to give a value greater than 1, but this would mean the bar is going to overflow, and we don't want that. That's why we limit to the 1. We create a new vector named new HP size, and on its y value, we just get the y value of the HP bar's y value, so it will not change. But for the x value, we are going to calculate it by multiplying the percent of the HP by the max HP. So let's say this is 50%, we multiply it by our max size, so only half of the bar will be filled. Since we have set the pivot to the west, the bar will move towards the left. We do the same with XP. Instead of max HP, we use needed XP and do the same. After that, we also update the level text and get our current level from the game manager. Now, on the onMessage function, we check for two messages. If we get an update UI message, that means something has changed with the UI, so we need to update it. You can call this function on the update too, but there is no need to update the UI on every frame, so we only update it when we need it. If we get a message that says skills, then that means it's time for player to select new skills, so we set the selection UI. Let's go to the set selection UI. With this function, we set the skill selection UI. We stop the game by setting the time step to 0. We set the is selection time to true, so when we click somewhere around here, it will not be ignored and we will be able to select the skill. We enable the background so player will be able to see it. We create a skill case table and we use table.insert to save the keys from the skills. So this will basically save these skills on the skill keys. After that, we use this part to shuffle the table, because when selecting skills, we will be getting the first key on the table. That's why we need to shuffle it to avoid getting the same skills each time. After that, we iterate through the options. Options is the table that has 3 entries, option 1, option 2, and option 3, and each of them have their table with node, name, image, and description. The first thing that returns is the option name, so this will be option 1, 2, or 3, and the other is option nodes, which will return the table of that option name. To get the first key from the table, we use table.remove. This removes the keys from the first play of the skill keys, but also returns it, so we can save it on the skill name. Then we get the skill data using the skill name from the skills table. After we get our skill name and data, then we can update our option. We need to update the name, description, and the texture. So we update the name, description, and the image. We use GUI.setText to set the name and the description. Then we use GUI.playFlipbook to change the texture. Now, on our onInput function, we first check if we are not selecting a skill or we have yet to lose. That means we don't need a reason to interact with the UI, because we only interact with the UI when we are selecting a skill, we click on the skill we want, or we click the reply button. If neither of them is the case, that means we don't need to check the rest, so we just return. If that is not the case, that means we are either selecting a skill or we have lost. So we can check. We checked if we have just clicked, and the click is on the replay button. We also have lost. That means we are trying to replay the game. So we call the GameManager's resetGame function to reset the values, and we send a message to our scene parent telling it to change the scene to the level. Since our current scene is already level, it will be reloading the level. If this is not true, then we check for the options and see if we have clicked on any of them. If we have clicked on the option 1, we call the apply selection with option 1's name. We do the same for the option 2 and 3. Now let's check the apply selection function. This is a direct function. We check if the selected skill is max HP increase. If that is the case, we get our HP and max HP. We calculate the addition, which will be the 25% of our max HP. So we increase our HP and max HP by the addition and set the values on the game manager. We basically follow a similar approach. For the small increase, we add 15%. For the speed, we add 20%. For armor, we increase the armor value on the game manager by 2. And for small armor, we increase it by 1. So basically, this will be the part where the logic of the skill being applied. Since we selected the skill HP store, then we will increase our HP by 30, or we can do this maybe max HP times 0.3. So when we increase our max HP, the restored amount will also increase. If we select the poison damage, it will increase the poison damage by, let's say, 4. Since enemies, after being hit once, check for the poison damage regularly, they will get 4 or more damage, since we have just increased it. If we get more arrow, we send a more arrow message to the player. We have already seen it, it increases the amount of arrow player has. And for the more axe, we send the more axe message to the player. When we first selected the axe skill, we will need to add it to this slot. We will edit when we do not have the axe. We will set it to true, so we won't be setting the texture again and again. We increase our attack skill amount, because if we first get the trap skill and we get the axe skill, then axe will need to be on the third slot, and we need to know this. If we currently have 2 skills, that means it needs to be on the skill 2. If we have 3, then it needs to be on the skill 3. After that, we also need to enable the skill 2 texture, because if you remember, they actually have a texture. It is just not enabled, so we change the texture and enable it to be able to see it. Same with the bear trap, we send a more trap to the player. If we don't have it yet, we set the texture. We update the UI bar and we disable the selection background. Also, we make the game continue by setting the time step to 1. And with this, we are basically done. I know it was a bit chaotic, and the methods I have followed during the development may not be the ideal way to do it, but they work, and I think this is what matters, especially if you are just beginning. And that's it. That's how you can have a roguelike game with Defold. I will upload this project file to my itch.io page, so you can go and download it from there. If you have any question, you can ask in the comment section. On the channel, you can find tutorials on different topics. So if you didn't understand some part of this tutorial, you can go and watch the other ones to understand it better. Thank you for watching and have a nice day. And now, gameplay time.